Alright, so I'm going to be showing which of these are polar. So first step is going to be you're going to want to write out the Lewis structure of each one separately. And so for the SO3, we're going to, we know that this has, for the valence electrons, it's going to have 6 from the sulfur and then 6 from each oxygen times 3. So that leaves 24 valence electrons. Okay, so when we're going to need that when drawing the Lewis structure. And so in drawing it, we're going to put the S in the middle and connect that with each oxygen. And we know that it's going to make double bonds with all of them because the oxygens like to have two bonds always, and the sulfur is at a place on the periodic table where it can have I'm breaking the octet rule with it, but that's okay because it is below the line where it can actually break the octet rule. And so once I'm done drawing the Lewis structure, I see that I've fulfilled the octet on all the oxygens, and if I were to count my electrons, right now I go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So that's 24, that's perfect. Okay, next I'm going to want to draw the dipoles, and I know that oxygen is more electronegative than sulfur, so my bond dipoles are going to go out toward each oxygen. But this isn't an actual picture of the molecule, this is just the Lewis structure with its dipoles. So the actual SO3 is going to be trigonal planar. It's going to look a lot like that with 120-degree angles. And so these are all double bonds, and there are no other domains, so it's 3 domains. So when we draw the vector dipoles, it's going to look like that because that's like that. So it's an XY coordinates, and that one goes up. So that's going to cancel with these two are going to cancel, and so we're left with no dipole, no net dipole. Net dipole is going to be 0, so we know that this one is going to be non-polar. Alright, and so the next one is going to be OF2, right? And so for the OF2, the Lewis structure, we know to put the O, connect it with the F, fluorine. Now we got to find the valence electrons. So we know the oxygen has 6, and then each fluorine has 7. And so that's going to leave us with 20 total. And we start on the outside and fill them up. We know that fluorine has an odd number of valence electrons, so it's okay not to have the octet. It's going to have 6 around it along with the bond, 6 electrons around it along with the bond. And then we know that the oxygen, we're going to have 4 left over at this point, 4 more electrons, and so we just place them around the oxygen, so the oxygen has the octet also. And so we know that the oxygen is going to have, so we know that this molecule is going to have 4 domains. And we know that the fluorine is going to be attracting the oxygen. So the fluorine is going to be slightly negative, and the oxygen is going to be slightly positive. And so when we draw the Lewis structure, the actual structure from